Alright, we're going to go over stoichiometry, specifically limiting reactant questions. These are reactions or questions where they give you amounts for two different reactants. Your job is for how much product should be produced. So the first thing you need to do, if they give you grams, go to moles. And the way you do that, you divide by the molar mass of each chemical. Step 2, divide those mole values by their coefficient from the balance equation. If you look down here, that's the 2 and 3. Those are your coefficients along with the 2. So if I had nitrogen and hydrogen as my reactants, I'll divide by the 2 and the 3 in this step. Whichever one's smaller is considered my limiting reactant. That's the one I will take to step 3. I multiply that by the coefficient what I'm looking for, which once again here will be the 2 moles of ammonia. Step 4, multiply by the molar mass if you need to go to grams, and that will be 17 grams per mole if we're looking at this ammonia example again. The key to understanding this is that step 2 and 3 is always required, any stoic question. The only thing that's not required is step 1 and 4. It really depends on what you're given and what you're looking for. So let's take a look how this works out. So the first question I'm asked for how many grams of ammonia. So I'm going to circle what I'm looking for, underline what I'm given, so I don't get lost. And now this is going to be a 4-step question. So step 1, 2, 3, and 4. First step, remember, is go to moles. So you're going to take your 14 grams of nitrogen, make a T-chart, 28 grams, 1 mole, so that's 0.5 moles of nitrogen. Do the same thing for the hydrogen, 6 grams of H2, molar mass is 2 grams, 1 mole, left with 3 moles of H2. I'm going to take both these quantities, divide by their coefficients. So 0.5 moles of N2. So the coefficient for nitrogen is 2. So divide by 2 moles of N2. The moles of N2 cancel out. We're left with just a number, which is 0.25. Do that again for 3 moles of H2. Divide by the molar mass, which is a 3. So 3 moles of H2. And left with just 1. So this is smaller. That's my limiting reactant, and that's what I'm going to take to step 3. So 3, 0.25, multiply with the coefficient what I'm looking for, 2 moles of NH3, and I'll be getting 0.5 moles of NH3. And so I need to go to grams, 0.5 moles of NH3, multiply by the molar mass, which from the periodic table is 17 grams, 1 mole. That gives me about 8.5 grams of NH3, and I'm done. So this is basically telling you that if you react this amount of nitrogen with this amount of hydrogen, you could only produce 8.5 grams of ammonia. The reason being is that your nitrogen is going to run out first, and as a result, you can't produce any more once that's all used up. All right, so if you look at the second example, we're going to be taking the same reaction, and now in this situation, we have 4 moles of nitrogen. So underline that, 9 moles of hydrogen, and we're looking for grams of ammonia. So whereas for the previous example required step 1, this one does not. So this one only requires step 2 and 3 and 4. 2 and 3 are always required for stoic. So take your 4 moles of nitrogen, divide by the coefficient, which is 2 moles of nitrogen. That gives me 2. Do the same thing for hydrogen. 9 moles of H2. Divide by the coefficient, which is 3 moles of H2. Yeah, for 3. This is smaller. Limiting reactant. Take that 2, multiply by the coefficient what I'm looking for. So that'd be a total of 4 moles of NH3. And because I need to go to grams, multiply that 4 moles of NH3 by the molar mass, which is 17 grams, 1 mole, which is 3468 grams of NH3, and you're done. Notice how I always try to identify the chemicals as I go so I don't get lost. That's important to do as well. So step 3, you're going from moles to moles. So we're looking for moles of ammonia. And we're given 8 moles of nitrogen, 6 moles of hydrogen. So step 2 and 3 is the only thing you need. So take your 8 moles of N2, divide by the coefficient, which is 2 moles of N2. That gives you 4. Do the same thing for the hydrogen, 6 moles of H2. Divide by the coefficient, which is 3 moles of H2. That gives me a total of 2. Smaller limiting reactant. Take that step 3. 2 times coefficient what I'm looking for, 2 moles of NH3. Gives me a total of 4 moles of NH3, and I'm done because I'm just trying to go from moles to moles. All right, last example, we're going to go from grams to moles. So for this one, same logic. You're looking for moles of ammonia. So there's my circle. Getting 56 grams of nitrogen, 20 grams of hydrogen. So how many steps do I need? Well, I need to go definitely from grams. So step 1, 2, and 3. And that's it. So take your 56 grams of N2 to your T chart, which is 28 grams, 1 mole. Gives me 2 moles of nitrogen. Do the same thing with 20 grams of hydrogen. Molar mass is 2 grams, 1 mole. So 20 divided by 2 gives you 10 moles of H2. Now divide both of them by the coefficient, 2 moles of N2. Coefficient is 2 moles of N2. Gives you 1. 10 moles of H2. Divided by the coefficient, which is 3 moles H2. So that's going to be what, 3 1/3, so about 3.33. This is smaller limiting reactant. 1 times the coefficient which you're looking for, which is 2 moles of NH3. My answer is 2 moles of NH3. And that's it. So once again, here, if you react 56 grams of nitrogen with 20 grams of hydrogen, you're only able to produce 2 moles of ammonia.